Finding the angle from this triangle. So here we have the ratio of two sides. So relative to angle A, we have the adjacent side and the hypotenuse. Okay, so if I go back up to my SOHCAHTOA, adjacent and hypotenuse is a cosine ratio. So I just need to make sure that I have the right ratio. So in this particular example here, the adjacent to hypotenuse ratio, that's going to be my cosine ratio. So equals, so remember that the cosine equals that ratio. And so if I tell my calculator angle A, I get the ratio 12 to 13, but I don't have the angle. So I need to do the opposite. So my input needs to be my ratio, and my output needs to be my angle. So in this case here, I'm going to use the inverse cosine, and that will then give me the output of angle A. So typing that into my calculator, okay, so I do second cosine of 12 over 13, and my angle A that I end up getting from my calculator is 22.619, so I'm going to round that to 62 degrees. And that looks about right. Okay, if my shape is given by the ratio of 12 to 13, the angle looks to be about 22.62 degrees. That seems about right. So again, we need to make sure that we understand that we are going from the ratio description of the shape to the angle description of shape. Every time we need to translate between the two, we need our calculator to help us do this. And it's important to know that we use our cosine when we start with angle and with ratio. We use the inverse when we start with ratio and end with angle. So here, we're being asked to find these different angles. Okay, so this here, again, we have the adjacent and hypotenuse. So I'm just going to write this out. So I have cosine of angle A. So my input is angle A. My output would be the ratio adjacent to hypotenuse, okay, which is 17 over 20. So again, this is the wrong way around. I don't need an output of the ratio. I need the output to be the angle. So then I need to use the other function, the inverse function. And then I'm going to type this into my calculator. Okay, so there, if I use the opposite function of cosine, or the inverse cosine, or what's also called the arc cosine of 17 over 20, I get the angle A. So I go to my calculator now. I can't do this in my head. I need to use my calculator, okay, because my calculator will convert this from this ratio to an angle. And my calculator is giving me an angle of 31.788, so I'm going to round that to 79 degrees. Okay, so if that is about, 85% of the length of the hypotenuse, okay, the angle should be about 31 or 32 degrees. So going to the next one here. Here I have my angle, and then the two sides, and I could always work out the third side using Pythagoras. If I have two sides, I can use Pythagoras, but I'm just going to use the side they gave me. So here, the angle that the sides I have are opposite and adjacent, so that's my tan ratio. So I need to, if you're not sure, you go back up to your SOHCAHTOA. Okay, SOHCAHTOA, opposite and adjacent is TOA, so that's tan. Okay, so then I go to my ratio here. The ratio is tan of angle A. So if I know my angle, my ratio is going to be 32 over 34. This is the wrong way around. I need to solve for the angle, so I need to use the inverse tan. So if I tell the calculator my slope, it should give me the angle. So going to my calculator then, the slope is 32 divided by 34. The angle should be a little bit less than 45 degrees, right? Because that's a little bit shorter than this side. When I use my calculator to solve for angle A works out to be 43.26 degrees. Okay? And again, some of you might get used to just kind of typing this into your calculator. you not even writing this down, but it's really important that you actually write down the notation in both ways. Okay, it's important to get used to doing that because as we get further in math, it's really important to keep track of this.